Okay, so what we're gonna do now is I'm gonna delete this. Delete. So we have worked through this kind of setup for our main and then our helper.c. Okay. What we're gonna do now is work with the CMake module path. So we're going to set, this is a variable in CMake module path. We're going to set that in our source directory /CMake. Then we're going to close and be done. Then we're going to print a message and tell people where is our module path. So let's do that. Let's compile it. Let's see how it goes. Build. Maybe I need to make directory. Let's remove the current build and then make directory build cd build CMake. Okay, CMake module path is blank. I wonder if we need some quotation marks or something. Ah, we do not. We need to do this. Alright, let's see. Okay, CMake module path is, that's weird. /CMake. Ah, it's because I have that there. Let's do that again. Okay, so what we're going to do with our module path is we're going to create a new file and we're going to save it as, let's go back to this, new folder, CMake. Let's call it, I know what I'm going to call this already, but we'll see why we call it this in a second. Save. So now we're going to go and take some print statements out of this and just do this inside of find port audio.cmake. And then let's get rid of this CMakeLists.txt. Now let's put down here that we're finished inside here. So let's run this again. You'll see that we never actually make it inside this folder because we need to put a command in here that says, let's find this project. So find package, sorry, we need to find the package port audio, and then that's required. So let's do this again. So now we're inside of this file, and essentially what this does is it says, hey, go to the CMake module path and find all the required file path or required paths, and we'll see what those do in a little bit. I wanted to make a point about the syntax here because you see if I don't name this in the convention of like find port audio.cmake, you'll see it won't find this path. So see, it's like could not find package configuration, so it has to be set as this, right? Like this find, and then your characters would go, and here .cmake is a syntax part of, it's a syntax part of this whole thing. Okay, so now let's go in here and say like find path, port audio directories names port audio.h. Let's do the spacing the way I like it. Message, and then let's just print a status message that says port audio dir. And then let's see if this works. I was having some trouble with this earlier and I don't really know why. Okay, great. So a better way to structure this is if we say if port audio dir directory message found at. So let's say this was found at whatever that was. What did I mess up? Oh, I need an end here, end if. So that's the syntax for an if statement. So port audio.h found at user.include. Next, I should add a case to this that says else. And then this is just the syntax for the if-else statement in CMakeLists. I don't know who came up with it or why, but you never know. .h not found. Okay, so let's actually show what this kind of thing does. So what this is telling me is that it's found my header file, which I need to include, because there are two things I need to include with a project or a target or an executable in C or C++. I need to include directories and libraries. So directories are folders, right? Like user/include is a folder structure that has a lot of files in it. And then a library is typically a .so or shared object file that contains compiled code. And library could also just be a bunch of files that sit in with each other, but kind of either or. It's either compiled code that you can just access with the functions that you have in your header file or in your include directories, and then libraries are more complete chunks of code. So the next thing we do is we say find library port audio lib. This is short for lib, and then the name will be port audio. Okay, and then we're going to do the same kind of thing. Let's run this to make sure I got the syntax right. Okay, so next I want to copy and paste this structure, and then I'm just going to change this for now, and it'll print out the wrong message, but we will say this port audio. Okay, so you can see kind of how we modify that structure. So this .so means shared object, which is, I think it's compiled code. So it's like its own little executable or little library that you can work through. I don't know if it's compiled code or not, actually. I just know you need to include this, LOL. Okay, so I'm not sure if I need to give a parent scope to this the same way we did in the other file to make sources appear, but we're going to go through it anyway. So let me delete this line. Target include directories, and then let's give it our port audio directories. So we have to have a target, then we have a connection type, private, public, whatever you want it to be. There's reasons for choosing different things, but you'll get there with time. This is more about how to do this and be comfortable with it. Okay, so now I've included my directory, and the next thing I need to do is link my target, link libraries, my executable, private, then let's copy and paste that name, port audio lib. Port audio lib. Okay, let's do a CMake on this, and let's do a make. Great. Okay, so the other package we need to find is called SND file. I don't know what that actually stands for, but it's like SND file.cmake. Then let's open that with a text editor. Shoot, I guess I shouldn't do that. Let's delete that. Delete. Nope. Okay. So let me open a new file and save it as what we need to. So this is really like, it's not, I didn't make this up. Someone else who built this tool made up the syntax, like find SND file. So I'm going to go ahead and copy this entire thing and then start making edits to the name, because we are in SND file. And we're going to do the same thing we did in port audio, but for SND. So we need to find the path and the library. So let me do SND file directory names. SND file.h. I want this to go like this. SND file libraries. We're actually going to make our own .so file here, so shared executable, shoot, I wanted to do this. So I can just copy and paste this whole thing like this, and then like this, and then let's compile. Oops, what am I doing? Let's run our CMake. So we haven't included the find port audio command yet. Sorry, the find SND file, but that's what we're going to do now. And let's do a CMake. So you can see we've now set our CMake module path, which is where we can keep track of our external directories and libraries. And then port audio.cmake, we find its include directory and then its library. And then we do the same thing for SND file. The next thing we need to do is to add those to our link, to our links. So we need to, let me back up and try and explain this. And include library, and include directory and include library. Tell your compiler when you are running, hey, where is the header file that defines all the terms I'm going to be using? So if you remember our header file, right, we have the source, we have our source folder, and then we have our own header file. It needs to know what this function does and what it input, like what's its input. And then our shared object or our libraries contain the code that tells our compiler, hey, what's going on? So our compiler is aware of this code, and it can compile. But it'll compile each in C++. It's easier to explain because it'll compile chunks of code as objects and then link these objects. The same kind of effect is going on here, where we compile, like, I don't know exactly how they compile in C actually, but I'm assuming it's probably fairly similar to C++. The idea is you need to make your compiler and your linker aware of all of the code that you want to use. So in C and C++, you have header files, and then you have all the code that's defined elsewhere, right? So like include directories would tell you this kind of information, and then include libraries would have shared objects that are compiled code, or libraries that are accessible code like this. So you need to tell the compiler and the linker, hey, here's all my source file, here's my code, and then here's all the code that I need to support my program. So let's go ahead and do a CMake and make sure we get all this. And then we're going to open up our main, and then we're going to include what's it called? Port audio.h, and we're going to include snd file.h. This is for sampling the audio buffers, and then this is for saving as data as a .wav file. So let's go ahead and compile, run our make, and then let's actually run this code and see if we get any runtime errors. Let me just / this. This is the run command, my executable. All right, we're good. Hooray! So that's how you set up includes libraries in C++, in C and C++. It's the same idea. You have essentially the edits we made to this file sit right here and right here. So I'll go ahead and use the control to maybe it's shift. No, it doesn't work. So let's go through these first. So this CMake module path is a built-in variable to CMake. It contains the path to the setup modules, these find CMake, and they also have configuration.config files. They're also named that as well. So what I do is I print this mess. I set ours because we are working in the source, and our file structure is such that this is our source directory. We have src for our code sources. Then we have our CMake, and then our build. So our project structure is such that our source directory /CMake is where all of these find setup files are. And then we use this command, which tells CMake to go to this module path and look for a file called find portaudio.cmake. We come in here, we use the find path and find library commands to find the header files and then all the supporting compiled code or just code that you need to run this program. And we print an output message that tells the status of the directory and the library. These are returned to our root CMake list, and we add an executable here. This is our target. We then tell the target that these directories exist, and then we tell the linker that these libraries exist, so that the linker knows who needs to see what and how to connect function calls to different parts of the program. So that's an example of how to use the setup tool and the CMake module path. So up to now we've gone through actually a pretty decent CMake structure and how to organize your files so that you can build projects in a pretty easy way. So all right, that's where